Hello everybody, welcome back, and we are going to be dealing with exponential equations. Now first things first, why on earth is there an x in my equation, in my exponent? What are we doing? Why are we making math so difficult? Well, let me tell you that this is actually not that bad. It looks intimidating, but it's actually nice when you realize it. It's actually quite easy. Because all you will really be doing is just exponent laws, and that's it. And let me show you something, right? Think about an equation such as this. If we have 2 to the power of x is equal to, let's say, 2 to the power of 5, right? How will these two be the same? Sorry. How will these two be equal to each other? What do we need to let x be equal so that this is satisfied? Do you not agree that if x is equal to 5, then therefore these values are going to be the same? That just tells us that it's 2 to the power of 5, which is equal to 2 to the power of 5, and that is indeed true, which both of them is going to be 32. Okay. So therefore, we need to get to a point where we have the same bases, and as soon as we have the same basis, note what's actually going to happen. So let me rather show you what it's going to look like in the process. So when we have the same bases, we can actually drop the bases in that case over here. And then we can say that this tells us we're going to be saying that x, the exponent on the left-hand side, is the same as the exponent on the right-hand side. Because we just dealt with the bases already. So all we need to do with is the exponents. The exponents. So I have I'm a bit sick, so yeah, my apologies. So right now, what we need to do is we need to find a way to make the basis the same such that we are only going to be working with the exponents. Hopefully that makes sense. So now we are given this question. Solve for x if 27 to the power of x is equal to 1 over 9. So first things first, we need to note how are we going to get the same base. So we know that 27 can be written into exponent form, and we want to write it as a prime number, as simple as we can at the moment, okay? So we can rewrite 27 as 3 to the power of 3. That is the smallest base we can get from this, okay? And we can write 1 over 9 using exponent laws with negative exponents in the form of 1 over 3 to the power of 2, right? Because 9 is the same as 3 to the power of 2. But notice that the 2 is positive in the exponent, so therefore we can write it as 3 to the power of negative 2, which is also 1 times 3 to the power of negative 2, because the 1 is in the numerator, which is just 3 to the negative 2. So that is what we are going to be doing. 27 is the same as 3 to the power of 3, and this is all raised to the power of x, and this is equal to 3 to the power of negative 2, using exponent laws. And we know from the other exponent laws that when we have exponents raised to each other, we can just multiply them. So therefore, we have 3 to the power of 3x is equal to 3 to the power of negative 2. Now what do you notice here? Notice that the base on the left-hand side is the same as the base on the right-hand side, meaning we're done with the bases. Now we just need to figure out what is the exponents going to be. What is x values going to be using exponents? So we need to let the exponents be equal to each other, such that we have 3x is equal to negative 2, meaning we need to solve for the exponents now, okay? Hopefully this makes more sense now. And obviously, in order to get x on its own, we need to divide both sides by 3. So therefore, x is just equal to negative 2 over 3. Alright, if that was a bit overwhelming, I'll understand. But let's get into another example, just for practice purposes. Okay, so this is a very nice question, okay? So solve for x if we have 3 to the power of x plus 2 multiplied by 3 to the power of x plus 3 minus 3 to the x is equal to 315. Now, how on earth are we going to do this? So first things first, remember the whole plan. The whole plan is for us to get the bases on both sides to be the same, so that we have an exponent as well for each base. So how are we going to do this? Well, notice that we can use exponent laws. The exponent law that tells us that if we have a to the power of n plus m, this is the same as saying it should be a to the power of n multiplied by a to the power of m. So we basically just multiply the bases with their respective exponents to be for each base that we duplicated, if that makes sense. Alright, so we're going to do that for this one. 3 to the power of x plus 2 is the same as 3 to the power of x multiplied by 3 to the power of 2. Multiplied by, and what do we notice here? Also, I do want to apologize. This is a plus sign over here. I didn't really notice that. I think it was printing issues. So this is a plus, if that makes sense. Because I was thinking, this one didn't make sense really. But at the same time, let's get into this one. We have 3 to the power of x times 3 to the power of 2 from the first one. Now the second term is 3 to the power of x plus 3. So we'll say 3 to the x multiplied by 3 to the 3. Minus 3 to the x equals to 315. Okay, now what? What do we notice from each and every term on the left hand side? Do we notice that 3 to the power of x is in this term, 3 to the power of x is in this term, and 3 to the power of x is in that term? They are high common factors. They are common factors. So we can take that out as a common factor. And what are we left with? The remainders. 3 squared plus 3 cubed minus 1. Because remember, if you take out an entire term as a factor, you'll just be remaining with 1. So therefore, what we're going to say for this one, I'm going to keep the 1 there, is that we are going to have 3 squared, which is just 9, plus 3 cubed, which is just 27, and 1, it's just going to be minus 1. And this is equal to 315. And then we have to simplify this. 3 to the power of x into 9 plus 7, which is just going to be equal to 36, minus 1, so that's just going to be 35, equals to 315. Okay, and then all we need to do is get 3 to the power of x on its own, so we divide both sides by 35, and 315 divided by 35, right, what is that going to give us? Well, if you put it in your calculator, or if you do long division, or whatever method you used, you'll get 9. And what is 9 represented as? We have 3 to the power of x is equal to 3 squared. And do we notice now that the bases are now the same? Meaning we can drop these bases away, and now we can only work with the exponents. And in this case, x is equal to 2. And that is our answer. So if we plug in x equals 2 into the original equation, notice that we are going to get the answer of 315. Okay, we'll do one more example and we can call it a day for this lesson. Okay, so I had to give a question like this. This has to be shown in an example, so let's do it. We have 2 to the power of 2x minus 2 to the power of x equals to 2, and we need to solve for x. Now first things first, what on earth are we going to do here? Because clearly in the other examples it was more simple, right? In this case over here, we have 2 to the power of 2x, but this time it's not an addition of exponents, it's multiplication of exponents, 2 times x. So we can either write, using exponent laws, 2 to the power of x as 2 squared to the power of x, remember, because they're multiplying each other, or we can write it as 2 to the power of x raised to the power of 2. So I want you to analyze both of them and see. My question is, and I'm going to write it like this as well, is there a repetition? Does this use reference to something that we've just covered a few lessons ago? 2 to the power of x raised to the power of 2 minus 2 to the power of x. Isn't that just a repetition? So wouldn't we use k method? Where clearly we are going to let k be equal to 2 to the power of x. In this case over here, obviously, and for this one here. Such that what this implies to us is that we are going to have, so remember, what do we have? 2 to the power of x equals to, raised to the power of 2 minus 2 to the power of x equals to 2. And therefore this implies to us that we are just going to replace k with 2 to the x with k. So it's going to be k raised to the power of 2 minus, and it's just going to be k okay, equals to 2. And then from there, what do we notice? It's just going to be k squared minus k. And we have some type of quadratic equation, so let's take the 2 over to the other side. We minus both sides by 2, we have minus 2 equals 0. And then we solve for k. It's literally just a quadratic. We just look for these patterns, we try to analyze, not overanalyze, but we try and analyze the things that we have. And we use the mathematical rules that we know, and we're not going to make up any. Okay, so in this case, we are just going to be factorizing. So notice that k squared on the left hand side can be written as k times k, and then 2 can be written as 1 times 2 because it's a prime number. So therefore, we'll have k, and then also k on the left hand side here, and this is equal to 0. And then 2 can be written as 1 and 2, and what gives us the 1 over here? Clearly 2 minus 1 gives us 1. So let's work with our operators. The negative goes to the biggest one, and then negative and a negative gives us the remaining, which is a positive. And then what do we notice? This implies to us that k plus 1 is equal to 0, or k minus 2 is equal to 0. And then that implies to us that we are going to have k is equal to negative 1, okay, or k is equal to 2, okay. Alright, and now let's see what we're going to do here. What is the question? It said solve for x, so we need to now replace k with, what did we let k be equal to? 2 to the power of x, okay. So we remember that k is equal to 2 to the power of x, so we just say 2 to the power of x equals negative 1, or 2 to the power of x equals to 2 to the power of 1. Okay, because now what we can see on the right hand side is that the bases are the same, and therefore that actually tells us that x is equal to 1. Because the bases are the same, we work with the exponents only. But my question to you is, what about this side here? What are we talking about? 2 to the power of x equals to negative 1. Can this value, for any x value, ever be negative as an output? Because notice that clearly, even if we have 2 to the power of 4, this is just going to be a positive value, right? But what happens if we have a negative x value? Let's say negative 3. Then this is just the same as what? 1 over 2 to the power of 3, because of exponent laws, which is 1 over 8, which is still positive. So therefore, this can never be negative 1. These types of questions are here to trick you. You can never solve for x in this case over here, so therefore you'll exclude it. If you want to write down some information here, and let me just rather write this in red, because then at least you can see. Then you can say that an exponent expression like this can never be negative, and that is why you're excluding it. So you can give your reasoning, and you can show that you understand your work to your teacher, and you can make them happy. But otherwise, that is going to be exponential equations.